Okay, I have two quadratics here. What I'm doing is a problem on system of quadratics and conic sections. I look at these two different quadratics and I have to solve points of intersection. So this first one, 7x squared minus 5y squared, I have an x squared and a y squared, one positive, one negative, so this is going to be a hyperbola. And then the second equation in red is x squared and y squared, different coefficients. This is an ellipse. I did a previous video where I did linear combinations to get rid of an x squared or y squared. The problem here is if I added these two together, my y squareds would drop out, but I still have an x squared and a y. So on this one right here, what I need to do is solve with substitution. So what I'm going to do is this red equation, I'm going to get x squared by itself. So what I have is 21x squared, and I'll subtract 5y squared from both sides. So minus 5y squared. I'm going to divide both sides by 21. And dividing this by 21 is really the same thing as multiplying it by 1 over 21. Okay? Now I have x squared by itself. I'm going to take that x squared that I've solved for, and I'm going to plug it right in there. So I'm going to have that 7 times x squared, right? And that x squared is this whole thing here. Rather than have, I'm going to just put 1 over 21 out front like that. So I have 1 over 21 times 209 minus 5y squared. That's that 7x squared minus 5y squared plus 20y minus 3 is equal to 0, and I subtracted 3 from both sides. Nice thing about this right here is now I have a y squared, a y, and a singular term. It's going to be a quadratic. I might be able to factor it. Let's combine some terms first. I'm going to multiply that 7 through to get 7 over 21, which is the third.